Okay, welcome Year 11s to this short video tutorial. What I'm going to do is take you through the first part of this topic, which is linear graphs and models. This is the final topic that we do this semester before the exam. So the first thing that we want to look at is how we sketch linear graphs. Now, what we'll do is we'll start off with how we would originally do this, how we might have done this when we started doing this back in, say, Year 8 or Year 9. But then we're going to look at how we do it on the calculator, because effectively for this topic, in this subject, you don't need to be able, or you do need to be able to do it by hand. Obviously, you need to be able to draw these graphs by hand, but you can use the calculator to assist you in sketching these graphs. So linear graphs, these are straight line graphs. So generally, whenever we are sketching a graph, we need to show two coordinates. So we just need to show 2 points, mark their coordinates on the graph, and then label those. Use a ruler as well to draw your straight line graphs. That's obviously a given. But what you'll also need, obviously, for this lesson, you should have it with you, but you do need your calculator. And I'm going to bring up mine on the screen as well, like so. Just move it over a little bit so you can see it. Yeah, so make sure you've got your calculator with you as well, because we are going to use that a lot, as we do with most of our topics. Okay, so starting off with our linear graphs and models. So when we come to sketching, there are a couple of ways that you can sketch. You can sketch from a table, which is how you might have started out with your linear graphs a few years ago, or you can just sketch from the equation itself once you're familiar with what the equation means and what particular parts of the equation tells you about the graph. If you were asked to sketch from a table and you were given the graph, here we have it here, it's y equals 8 minus 2x. If you were asked to form a table using values for x is 0, 1, 2, 3, and 4, effectively what we're doing is we're substituting this x value into our rule to work out what would the y value be given that x value for this equation. So what I'm doing with each of these is I'm saying if x is 0, what is y? And this rule tells me y is equal to 8 minus 2 times the x value. So therefore, if I substitute that in, 8 minus 2 times 0, y must be equal to 8 when x is 0. So I can put that in there. So a table of values is substituting those x values into the rule. So if I do the next one, I'm not going to write it out because it should be fairly easy arithmetic. 2 times 1 is 2, so 8 minus 2 is 6. So I've substituted that value, that x value for 1, into this rule. The next one, 8 minus 2 times 2, so 8 minus 4. 8 minus 2 times 3. 2 times 3 is 6, so 8 minus 6. You can see a bit of a pattern emerging, which is what linear equations do. They give us a pattern. They give us a constant rate of change as well. We have here x is 4. 2 4s are 8, so this is 8 minus 8. And there we go. So here's our table of values. How do we get a table of values into a graph? Well, this table gives us the coordinates. This is saying when x is 0, y is 8. So that's the coordinate 0, 8. Remember, your x is always written first. This is the coordinate 1, 6, 2, 4, 3, 2, 4, 0. What we can do now to get a line is plot those. So here we have x-axis along here, y-axis down there. It is a little bit tough to see, so what I might do is see if I can get a straight line on that, just to highlight it a bit better. So there's our axes there. You can obviously highlight yours. You've got it in front of you. Here we have x is 0. That's where the axis is. That's where the y-axis is. And we need y is 8. So we've got that point right there. Now you've got to be careful when you're using these programs, as it doesn't want to let me draw on that. But what I want you to do is put a dot right on x is 0, y is 8. So right there where I've got the mouse at the moment, we need a solid dot because our line passes through that point. When you've got this relationship here, when we've got x, when x is 0, y is 8, it means that is where your line is passing through. When x is 1, y is 6. So when x is 1, y is 6. So I can put the solid dot there this time. When x is 2, y is 4. X is 3, y is 2. When x is 4, y is 0. But again, I'm going to have that same issue. Okay, so there we have it there. And then what we want to do is draw a straight line through those. So I might do it in a couple of stages. Down to there. Extend yours out so that it goes across the whole axis, but basically you want to make sure your line passes through all of those coordinates that we just marked in. Extend it out, and also what we can do is label it. So what we do is write the rule. The rule that gives us this line is y equals 8 minus 2x. We also mark in the intercepts. So the intercepts are where your line crosses the axes, I should say, so the vertical axis and the horizontal axis. So this one here, that coordinate was 0, 8. That one in there, and this one here was 4, 0. So there we have a line drawn from a table. You can actually use your calculator to get a table as well. I will show you how to do that. In some cases it's easier. What we want to do is on your menu page, go to lists and spreadsheets. You'll get these columns come up. We used these columns when we did our univariate data. What we can do is we can enter our x values into a column, like so 0 to 4. And in this column, we're going to have the y values. But what we're going to do, instead of calculating each one individually, we're going to use this shaded box, which is directly underneath the y. You'll see it's got an equals there. And what we want to do in this box is press equals. So the equals is directly under control. When you do that, you'll notice that y equals comes up. So whatever you've called this, which it'll always be y, but we put y, we press equals, it automatically comes up with y equals. Next we type in the equation, which was 8 minus 2x. You notice the x comes up in bold because we have numbers saved for x. Press enter and it asks you this question. It's asking you about this x, wants to know, are you talking about column x or are you talking about the variable x? And we're talking about the variable x. So you always change this to variable reference. We press OK and you'll notice that those numbers are automatically calculated, which is really handy. If you've got lots of x values or you've got a more complicated equation to type in here, it's much easier to do it using the calculator this way. Just don't forget it's variable reference. Okay, going back to our notes here, there's our beautiful line just drawn in there. What we're going to do is just do this example here. This is just a couple of straight line graphs drawn for us. You'll see they are labelled It's always important to label your graphs. Even if you've only got one on your axes, it is just common to make it very clear what was the equation that you used to get this particular line. It's especially important when you've got more than one graph on your set of axes because you want to know which one is which. So y is equal to 4 plus x, that's the one in the red, and y equals 8 minus 2x, that's the one in the blue. And you'll notice that's the same as the graph we just drew up there, y equals 8 minus 2x. Okay, so let's answer question A. Reading from the graph of y equals 4 plus x, so that's the red one. Let's determine these missing coordinates. So what they're saying is fill in the gaps here. And the last one is a gap with 9. So these coordinates obviously lie on the line, or the line passes through these coordinates. So what they're saying is, on this line, y equals 4x. When x is 0, what is the y value? So let's go to y equals 4 plus x. When x is 0, what is the y value? It's 4. When x is 2, what is the y value? It's 6. These last two, it's giving you the y value, not the x values. It's giving you the second number in the coordinate, which is always the y value. So when y is 7, what is the x value? So when y is 7, remember we're talking about the red graph first. 7 is here, so let's read along. Gets to this point here, x is 3. So the coordinate is 3, 7. This one passes through. And finally, when y is 9. When y is 9, that's this value here. X is 5. So we've filled in the coordinates for A. Now for B. Now we're reading from 8 minus 2x, which is this graph here. Now we need to determine these missing coordinates. Okay, make sure you read from the correct graph because that's a common error. Looking at the wrong graph would be something that, say, in a multiple choice question, that many people would make that mistake, trust me. So, this one, when x is 0, when x is 0, y is 8. When x is 1, y is 6. The last two, when y is 4, what is the x value? When y is 4, the x value is 2. And don't forget, it's the blue graph we're looking at. When y is 2, so over here, x value is 3. And you'll see that these coordinates match the ones that we had above there because it's the same graph. Okay, so what we've done is plot from a table, and we've just had a bit of a practice also with our coordinates, with our plotting itself. So what we're going to do now is have a look at how we can plot using the calculator. So on your sheet there are some screenshots of this, but I'm going to open up my calculator and show you how we do this. First thing is that we need to go to the graph page, which you'll see it's got a parabola on it. It's the second button along from calculator. And we're going to graph this one, which is y equals 2x plus 1. That's what we're going to graph. Okay, so here's the calculator. I'll go back to the home screen, and this is what we want here. Graphs. Now, depending on the calculator, sometimes this will come up at the bottom. It doesn't matter. Sometimes it's at the top, it's at the bottom. It depends on what version of calculator you have. Notice here it says F1X in a bracket. This is the same as saying Y. It's got an F there because F is for function, and we can do other types of graph on this set of axes. And I mean, in methods, in some later stages of maths, you do tend to use f of x, not y. But we don't need to worry about that. We use y. In all of our questions, we'll be using y. So this is saying y equals. So we have to imagine that whatever's before the equal sign is a y. It's a bit annoying, I know, but you just need to use your imagination. So our graph was y equals 2x plus 1. So f of x is equal to 2x plus 1. And we press enter. When you do that, you'll see the line immediately is shown, which is really handy. Now, if I needed to then graph this on paper, so if I was asked to show the graph for y equals 2x plus 1, it's no good having it on my calculator. I need to know, how do I get it onto the page? Okay, once you've got your graph appearing here, what we want to do is know what coordinates does it pass through. Because remember, to be able to graph something, you need to show two coordinates. And generally, you will show the intercepts. If there are two intercepts there, you will show those two. So, what we want to do is, if we go press on menu and then to trace and graph trace. So I went to menu, 5 and then 1. What comes up is this little cursor thing. And down the right hand corner you'll see that it's showing me the coordinate for where that cursor is. So this coordinate is 0, 1. What I can do is I can press this sideways button and you'll see I'm moving along the graph. It doesn't go up in integers, doesn't go up in whole numbers, it can go up in decimals. You'll see there's decimals down the bottom here. But what I want to do is I want this to come up. Did you notice when I highlighted that point, it's come up with y-intercept? I know it's the y-intercept as well because x is equal to 0. But when you scroll along, it will tell you when you reach the y-intercept, and that coordinate is down in the corner there, 0, 1. So that is the first point that I would mark on my page, on my set of axes. The other coordinate that I want is my x-intercept. So if I keep going, see this come up? It says 0. That is your x-coordinate. Your x-intercept, I should say. That is your x-intercept. So we have y-intercept, x-intercept. Negative 0.5, comma 0. So when I sketch, I would have my two axes, I would have a scale clearly shown, and I would mark in these two coordinates, the y-intercept and the 0, which is the x-intercept, and I would rule a straight line through those 2 points. I'd then label it y equals 2x plus 1. If I go back to your notes, this is all very clear in here. You can move along each point. Another thing that you can do is you can work out what is the coordinate for any x value that you have. So when I'm on graph trace, if I press, just say I wanted to know what's the value when x is 2, I just need to type in 2, and you'll notice this comes up, x equals 2. Press enter and it takes you to that point and it gives you the coordinate. I can also work out when x is, say, 5. It'll take me to that point. What if x is 100? It takes me to that point, and there it is down there, y is 201. When x is negative 1, takes me back down to where x is negative 1, negative 70. Any value for x I can type in here when I'm in graph trace. So remember, when you are in graph trace, you can get any value, any coordinate that this line passes through. I'll go back to the middle when x is 0. You notice that it doesn't take me back to that screen that I had before, but that's okay. There's other things that I can do if I fiddle around with this. I can go to Window, and I can zoom out. So if I zoom out from the center, you'll notice it's centered it for me. I can keep zooming out. You'll notice that my axes are getting, or my scale, it's getting smaller and smaller. Press exit and that'll get rid of that magnifying glass. I can zoom back in by pressing zoom in, like so. Might go a little bit further. There we go. Press exit, to get rid of that. To get rid of a graph, you can click on it and press delete and it will disappear. If ever you accidentally delete, just undo. So press Control, exit. It's got a little back arrow. It will undo the last thing that you did. Okay. Looking back, so we can get our intercepts using graph trace. In fact, we can get any coordinate. To plot, we need mark the two intercepts. Generally we do that except when, say, you've got an application question and you may only have one intercept showing. So a line will always have two intercepts unless it's horizontal or vertical, but sometimes you might just need to show 2 points. Most of the time though, mark your two intercepts on the plane, join them with a straight line, label the intercepts, and also label the straight line with its equation, so y equals. Now I just want to cover briefly what happens if your equation isn't in this form, doesn't look like y equals mx plus c. We can actually rearrange using our calculator. So I'm going to show you how we can do that. Just say you had this one, which is the equation is 2x plus 3y equals 9. It's an equation because it's got this equal sign in it, but it's not in the form y equals mx plus c, which is generally how we plot our straight line graphs. In this subject, we like it to be in that form. The reason we want it in that form as well is the calculator will require it to be in that form for us to graph it. So we've got 2x plus 3y equals 9. Now what we can do is if we want this to say y equals, all we need to do is solve for y. So we type it into solve and we put a comma y. So I'll do that now. If I go to, I'll open up a new one, calculator, and our solve is menu 3, 1. 2x plus 3y equals 9, comma, y. So we're solving for y. I'll just double check I wrote that right. 2x plus 3y equals 9. There it is there. Press enter. Now, it's come up with that, false, and the reason it's done that is because I've got things saved as x. See, I've got this stuff here as my x and y. So what I'm going to do, if ever that happens, is just close. Don't want to save, and do it again, because it means I've got things saved. It's probably handy that it came up because it saved you the hassle of asking me what's going on. 2x plus 3y equals 9, comma y. Press enter, and it's rearranged it. It's made y the subject. It now says y equals this here. Now it can look a bit ugly to us. This is only because we've got a fraction here. It doesn't matter. What we can do is highlight it and then copy it. So copy Control C, so just like on a computer. And if we go to our graph now, we can actually paste it there, which is Control V, just like on a computer. The only problem is it copies the y as well. See this bit here? Y equals, we don't need that, because this part at the front, that is my y equals. There's my graph there, and I'll press enter. And it has graphed that 2x plus 3y equals 9. It has graphed it for us. When labeling it, I wouldn't actually label it like this. I'd label it the way it was originally given to you, so 2x plus 3y equals 9, but it's not incorrect, so that's actually okay if you labeled it the way that it's rearranged it. From this point, I'd need my intercept, so remember menu, window, or trace, graph trace, and there's the first one, 0, 3. And if I move down this way, there's the 0, the x-intercept 4.5, 0. So I can now plot that on a set of axes on paper by drawing my axes, my y and x, marking in these two coordinates, 0, 3, and 4.50, and ruling a straight line that connects those 2 points, then finally labeling it with the equation. So that's what we do when it's not in the form that we want it. When it's not in the form y equals mx plus c, solve it for y, copy just by highlighting it. So once it looks like that, Control C, into your graph, Control V. So you might like to put that on the side to copy, Control C, to paste, Control V. Okay, now this bit down here is just telling you that you can zoom out, because sometimes when you graph an equation, say y equals x plus 30, you can't see it. So if I get rid of this one, highlight it and delete it, and then if I want to add one, you'll notice that my fx isn't there. I just have to go to Menu, Graph Entry, Function, and I'll get this to come back up. So if I wanted x plus 30, for example, and press enter, you notice I've graphed it, but it's not there. I can't see it. Have a look. The highest y value you've got here is 6.67 to negative 6.67. Now, if you can remember anything about your graphs, you would know that y equals x plus 30 has a y-intercept of 30. So that's why I can't see it, because it's actually crossing the y-axis a lot higher. So I'm too far zoomed in at the moment to see it. So like I did before, you can zoom out and you'll see that the line appears. There it is there. The other thing that you can do is if you go to Window and see this top one, Window Settings, I can actually change how much of the axis that I want to see. So the x minimum, just say I said, okay, I want the left-hand side of the axis to go to negative 50, and I want the right-hand side, so the positive x, to go to 50. Just leave your scale as auto, but the minimum y I can also change as well. I probably don't need it to be very low, but I'll just go negative 50 and 50 for this one as well, and I'll show you what this does. So negative 50 to 50 on both axes, and have a look, there it is, 50, negative 50, negative 50, 50. And there's my graph, I can see it now. I can now go to Trace, Graph Trace. There's my intercept there, 0, 30, which is what I expect looking at the equation. But I can also go all the way, if you hold it down, it'll take you all the way down to this point down here, which is 0. So we can see that it cuts through the x-axis at negative 30, 0. That's all explained here, and that's what I just did there. So you can make yourself a little note. This is how much of the x-axis do you want to see? And it's the same for y. How much of the y-axis do you need? So that's a good way, because sometimes you can see from the equation what the intercept is, and therefore you might want to make sure that that part of the axis is definitely shown so that you can see your graph. And that's the one that I just did there. So what you're going to need to do is have a practice with this graphing. So you're going to get a few different ones. They might be in a different form. They may not be in the form y equals mx plus c. In that case, rearrange it. Otherwise, make sure you get lots of practice using your calculator because, like I said before, you are allowed to use it to assist you. So why not make sure that you're really, really competent with it? Make sure that you know exactly how to graph a straight line on your calculator. Make sure you know exactly how to find different coordinates on that graph, how to find the intercepts on that graph as well. It is absolutely essential. Even if you have not been great with linear equations in the past, there is absolutely no reason why you can't do well with this topic because you do just need to be competent with this technology. It does help you immensely. Okay, I will set you some questions from exercise 3A and from exercise 3B. Okay, thank you very much for listening. Sorry that this is a little bit long, this video, but hopefully you've been able to fill in these examples. If not, you need to go back and pause where you need to so that you have got your own set of notes as well. Thank you.